This is the third video in the Indices, Surds and Logarithms Algebra topic of the Pure Math 1 course, and it's the second of video on indices, and in it we'll be looking at the rules around indices when the indices are fractions, and also some more problems involving indices. Now, in the last video we established these three rules involving indices where m and n are in integers, so that is whole numbers, positive and negative whole numbers. But what happens if m or n are fractions? What, for instance, might be meant by 2 to the power of a half? Well, if we multiply 2 to the power of a half by 2 to the power of a half, like that, then by the first of the three rules here, we should add the indices. So that would mean 2 to the power of a half plus a half is equal to 2 to the power of 1, which is 2. So 2 to the power of a half times 2 to the power of a half equals 2. Well, a number multiplied by itself, 2 to the power of half times 2 to the power of half, we would regard as the square root of a number. For instance, the square root of 2 times the square root of 2 is equal to 2 as well. So it would seem that 2 to the power of a half is the square root of 2. Now consider 2 to the power of a third times 2 to the power of a third times 2 to the power of a third. Well, by the first rule again, that would be 2 to the power of a third plus a third plus a third, which is 2 to the power of 1. So 2 to the power of a third is the number that you multiply by itself 3 times to get 2, or 2 to the power of a third would be the cube root of 2. In general then, a to the power of 1 over n is equal to the nth root of a. Now, in the when we had the index as a positive or negative whole number, we could have a as any number at all. But now this would only work if a is a positive number, because we know, for instance, that if we took the square root of a can't be negative. We can only take the square root of positive numbers. So now we have extended our indices to be fractions. We must restrict our number, to be positive. Now let's consider what we might mean by something like 8 to the power of 2/3, where we have a fraction of in the index of 2/3. Well, by the third of the rules, the third one, this is 1, 2 and 3, we know that a to the mn is a to the mn, so a to the 2/3 we might write as a to the third times 2, or 8 to the third by the rule squared. We know that 8 to the third means the square root of the cube root, beg pardon, of 3, of 2, of 8 even, cube root of 8, so that would be the cube root of 8 squared, and that is what we would mean by 8 to the 2/3. Of course, we could also have written this as 8 to the power of 2 times a third, that way round. So instead of a third times 2, we would have 2 times a third. So that would be 8 squared to the power of a third, and that then is the cube root of 8 squared. So 8 to the power of 2/3 is either the cube root of 8 squared, and the cube root of 8 is of course 2 squared, which is 4, or it's the cube root of 8 squared, which is the cube root of 64, which is also 4. So in general, a to the n over m is equal to the mth root of a to the power of n, or the mth root of a to the n. And we must have here a greater than 0. And we also must have m greater than 0, not equal to 0, as we can't divide by 0 in the fraction n over m. So the three rules here are true when m and n are fractions, provided a is greater than 0, and in fact they're true when m and n are any real numbers. M and n could be the square root of 2 itself, or it could be pi or any other irrational number, but we usually stick to just rational numbers. So if we want to evaluate a number like 125 over 8 to the power of 2/3, what that means is the cube root of 125 over 8 squared, and the cube root of 125 over 8 is the cube root of 125 divided by the cube root of 8 all squared. The cube root of 125 is 5, the cube root of 8 is 2 squared, which is 25 over 4. If we have a negative fraction in the index, like this one, 256 over 81 to the power of minus 3/4, then the negative, the minus, we can make it positive by having the reciprocal, if we remember. So this would mean the same as 1 over 256 over 81, which is 81 over 256 to the power of plus 3/4, which means the fourth root of 81 over 256 cubed, and the fourth root of 81 is 3, and the fourth root of 256 4. So it's 3/4 cubed, 3 cubed is 27, over 4 cubed is 64. Algebraic expressions can be simplified as well. 27p to the power of 6 to the 2/3 would be the cube root of 27p to the power of 6 squared, and the cube root of 27p to the power of 6 is the cube root of 27, which is 3, and the cube root of p to the power of 6, well, that's p to the power of 6 cube root times is a third, and we can multiply the indices. That would be p squared, a third of 6. So it's 3p squared, and then squared from this squared there, which is 3 squared, 9, and multiplying the indices, p squared squared is p to the power of 4. We can solve equations involving indices. For instance, 3 to the power of x equals 9 to the power of x minus 1, and in order to do this you've got to notice that 3 and 9 are related as 9 equals 3 squared, so we can replace the 9 by 3 squared. So we have 3 to the x is 3 squared to the x minus 1. We need in order to solve it to get the bases the same. So in this case we've now got the base as 3 is the same in both sides of the equation. Using the third rule of indices, I can multiply the indices here, so that would be 3 to the power of 2x minus 1. And now we can say, well, 3 to the x is 3 to the power of 2 to the x minus 1. Because the base is the same, the 3, we can say that x must equal 2x minus 1. And that's a simple linear equation. X is 2x minus 2, or taking x from both sides, we get x equals 2. Now pause the video and try these few problems. So A, oops, before you do it, part A should be 243 to the power of a fifth, 243 to the power of a fifth. Now pause the video. So part A, 243 to the power of a fifth is the fifth root of 243, and that is 3. Part B, 625 to the 0.25, well 0.25 is a quarter, so 625 to the quarter is the fourth root of 625, and that's 5. Part C, 5 and 1/16 to the power of a half. Well, writing that 5 and 1/16 as an improper fraction, that is 81 over 16 to the half, and that is the square root of 81, 9 over the square root of 16, which is 4. Part D, 125 over 216 to the minus a half. Well, when you see minus, turn the fraction upside down, we need the reciprocal. So we've got the cube root of 216 over 125, which is 6 over 5. Part E, 1 and 9/16 over to the power of 3 over 2. Well, again, we need to write that as an improper fraction, which would be 25 over 16, so 3 over 2. So that is the square root of 25 over 16, which is 5 over 4 cubed, which is 125 over 64. And part F, 81 over 16 to the minus 3/4. Again, turn the fraction upside down. 16 over 81 to the power 3/4, and that's the fourth root of 16 over 81, which will make 2 over 3 cubed is 8 over 27. You can of course cube 16 over 81 and then take the fourth root, but that would lead to much higher numbers. It's usually better to take the roots first and then deal with the top of the 3/4, the top of the fraction, and cube it. Now pause the video and try the following problems. So 2 part A, y times y to the power of 5/6 times y to the minus 3 over 2. We just add the indices. That would be y to the power of 1 plus 5 over 6 minus 3 over 2, which is a common denominator of 6, y to the 6 plus 5 plus 3 over 6, y to the 14 over 6, or y to the power of 7 over 3. Mistake there, that was minus 3 over 2, that should be minus 3 there, and so that is in fact y to the 11. Mistake again, 3 over 2 is in fact 9 over 6 of course, so that's 11 minus 9 is 2 over 6, which is of course y to the power of a third. Part B, Well, we can deal with the numbers first. We've got 4 times 3 over 6, and then we have the x's. We've got x to the power of 2/3, and then multiplied by x to the minus a 6th over x to the 3/4. So 4 3s are 12 over 6 is 2, and then we can add the indices for the first two there, plus minus a 6th, and then because we've got x to the 3/4 in the denominator, we subtract 3/4. So that's 2x to 2/3 minus a 6th minus 3/4, and to add the fractions in the indices there, we must have a common denominator of over 12. 3's into 12 go 4, 2's are 8. 6's into 12 go 2, times 1 is 2. 4's into 12 go 3. So we get 3 3's are 9. So 8 minus 2 is 6, minus 9 is minus 3. So that's 2x to the power of minus 3/12, which is 2x to the minus a quarter. 3a, 2 to the x plus 3 is 4 to the power of x. Notice that 4 is 2 squared, so I'd write 2 to the x plus 3 is 2 squared to the x. And using the third rule, the power rule, we can multiply 2x to 2x, 2 to the 2x. So 2 to the x plus 3 is 2 to the power of 2x. The bases are the same, 2, so x plus 3 equals 2x. And solving that equation, we get x equals 3. Part B, similarly, we notice that 36 is the same as 6 squared, and so we have 6 to the 3x minus 1 is 6 squared to the x plus 2. 6 to 3x minus 1, using the indices rule, is 6 to the 2x plus 2. The bases are the same, 6, so we have 3x minus 1 is 2x plus 2. 3x minus 1 is 2x plus 4. And then rearranging, subtracting 2x from both sides, we have x equals, adding 1 to both sides, 5. One more problem, this one here, 16 to the x plus 1 equals 8 to the 2x plus 1. In this case, 8 and 16 are not direct powers of each other, so you can't say that 16 is a power of 8, but we can say that both 8 and 16 are powers of 2. 16 is 2 to the power of 4, so that is 2 to the power of 4 to the x plus 1, and 8 is 2 to the power of 3, 2 cubed to the 2x plus 1. And so using the rule of indices, we have 2 to the 4x plus 1 equals 2 to the 3 into 2x plus 1, and therefore now we have the bases of the same, both 2. We have 4x plus 1 is 3 2x plus 1. Expanding the brackets, 4x plus 4 is 6x plus 3. Rearranging the equation, subtracting 4x from both sides, we'd have 6x minus 4x is 2x, and subtract 3 from both sides would say equals 1, so x is a half. This is the end of the second video on indices. Now return to Study Smart, where you will find a video on logarithms.